cosine law. Okay, so then consider triangles just to warm up here. Consider triangle ABC, in which angle A is 36, AB is 3, and AC is 6. So the problem here is that if we try to do sine law, why can't we do sine law? This is why we need cosine law. No, this is not quite.
Oh, question. I mean, answer.
Yeah.
Because we only have one angle.
No, one angle's okay, right?
Oh, because you don't have the opposite.
We don't have a comparison. We don't have a comparison. We don't know what 36 makes. And we don't know what angle makes 3 and what angle makes 6, so we can't set up our sine law because we don't know what it makes. Sine law, we at least have to have one comparison or a way to get a comparison of what angle makes for the ratio. So we can't use sine law on that question. Okay? So let's look at this. So use SOHCAHTOA diagram below to determine the length of BC. So we're going to do the roundabout way, and then we're going to use the cosine law here in a little bit. So what they've done is they drew a dotted line here to kind of get altitude. Since this is tilted, because it's an obtuse angle, it gives you the heights, not this slanted height. Okay? And so what you can do is that we can go ahead now and use the fact that this is a right triangle, right? And this angle is still 36. We're trying to find BC. Okay? So think about it in terms of two triangles. We're looking at this guy and then the big guy. So the point is that by drawing that straight down, I can figure out what CD is. Is everybody with me?
Yes.
Okay. Good. So we figure out what CD is. So CD is the opposite side, right? Opposite hypotenuse. So that's SOHCAHTOA. We can do it because we made a right triangle. So we have sine of 36 equals O, or CD, over 6. So 6 sine 36 is what CD equals. CD is 3.5267. Okay? So that's what this side is. Right there. So we got that. So now we have that. We're also going to just do a very similar setup. We're going to find out what AD is, the whole thing. Because if we know what AD is, we can figure out what BD is, right? Because we can subtract the 3 off. So we're going to find the whole thing of AD, which then that would be from 36 is the side adjacent, the side next to an hypotenuse. Then we're using cosine. Cosine of 36 equals, we'll call it adjacent, over 6. So then we're going to go 6 cos 36. Yep, 4.85. Okay, yep, 9.6. Or no, they have 4.1, but it's okay. So that's what the whole thing is. So then what is BD? You subtract 3 from it. So we'll say 1.85 is what BD is. Now, the reason I got BD is because now I can use Pythagorean theorem and find that hypotenuse. Okay, what hypotenuse? I'm talking about this side. Because right here and here. Okay, so you can go 1.85 squared plus 3.5267 squared equals 15.8753. And we have to square root that. Square rooting that will give me BC. So it's about 4. They're saying roughly 4. They rounded to. So it's close to 16. Okay. So that's the roundabout way of doing it. Notice there's some squaring, a little bit of square rooting. Okay, it's going to kind of make the formula make sense. But that's the roundabout way of having to handle the situation. Why this situation happened? Again, the reason that we can't use sine law here, I'll say it one more time, is because we don't know what 36 makes, we don't know what makes a 6, and we don't know what makes a 3. These missing pieces are a problem. We don't have any comparison. So the easy thing I do when I'm looking at these, when you look at these triangles, you say sine law. Do I know a comparison? Okay, if I don't, I'm using cosine law. Okay, that's kind of your strategy. Okay, so the cosine law, we're going to develop here real quick. Just do a little bit of proof on it. I won't get too crazy, but. All right, so cos of A equals AD over AC. So if we have cos of A is adjacent over the hypotenuse, which is x over b in those letterings. And the b comes from, remember, angle B makes side B. Angle B makes side B. Angle A, side A, etc. Okay? And so x equals b cosine A again, just like we did in our last proof for sine A. Okay, and on the right side, in triangle BDC, so that's a small one, we know that BC squared equals CD squared, so the altitude plus the leg squared. And we're going to plug those in because those are values. So we're going to plug in the H. We're just putting in H for the CD. And see, we don't know what dB is, but we know that it's going to be, up here's a, what's at the top there? A C, right? Angle C. So this side is really C. So C, the whole side, minus X, gives me that. That's what dB is. Okay, and so they're putting together here for you. They FOIL out these variables. Okay, so H squared. If you FOIL out C minus X, you get C squared minus 2CX plus X squared. You should be familiar with that pattern. Okay, that's just a FOILing out a perfect square binomial. We did that in Unit 2. And then here, we move H squared plus X squared. Well, H squared plus X squared, see that? What should that equal? H squared plus X squared. B squared. Should be equal to hypotenuse squared. And so then when they sub in B squared here. Okay? And we just figured out what X is. What's X? B cos A. So this is the cosine law. Good. I'll show you the patterns of it. Let me move it up here real quick. There's 3 ways you can do it, because you're not always looking for side A, right? You can look for side A, side B, or side C. So how you remember, okay, if whatever you're looking for is the angle you use, see that? And then whatever you're looking for, it's the other 2. So A is going to be B squared plus C squared, B, C squared plus A squared, C, A squared plus B squared, and then minus 2 times those same numbers. See the BC again? So the pattern's pretty consistent. You get these formulas, but you only get for the formula, they actually only give you this, just the one of them. They don't write all 3 ways. Okay? All right, so consider this triangle. Let's go ahead and use one here. Let's try it. So it's the one we've been talking about. We said this one, right? So we kind of know what the answer is going to be, but let's see what happens. They want us to find the length of BC. So what happens is that we are looking for side what? Yeah, which is A with the angles, right? So we want to use A squared equals B squared plus C squared minus 2BC cos A. Okay? We don't know this. That stays blank. We know everything else. B squared, 6 squared. C squared, 3 squared. Minus 2 times 6 times 3 cos 36. That's a calculation. That's all you have to do. That's just calculation now. Okay. Just calculate. So when you calculate that, you get that number we already saw. We get the 15.8753. And then we square root that. We round it to 4 for this one, for round the nearest tenth. So BC is 4 again. Okay. All right, let's do a couple more examples, and we're talking about the alternate form of the cosine law. Just because I know you want to be challenged. All right. Find the length the nearest tenth of a centimeter of the third side of triangle PQR. QP is 1.7. They're making me label here. So 1.7. QR is 3.1, and PQR is 110. So you see the problem here? Again, I don't know what 110 makes. I don't know what angle makes 1.7 or 3.1. Okay, so in this case, I am looking for side Q, which we can call A, if you'd like, however you want to do it. But you're going to go, essentially, the missing side. I'll just stay with Q. Let's say we're looking for Q squared is R plus P squared minus 2 cos 110. Any questions how we got that? Any values missing or anything for you? So when you calculate that, you get Q squared. Again, this is a calculation. Use brackets. Make sure you're in degree mode. Okay. We calculate this, you should get 16.104. And this is just coincidentally, we get Q is 4. Okay. Sorry, I'll slow down. Okay. All right. Now we'll do a little bit of an application one here. Yeah, yeah. All right. Questions? Okay, let's look at this one. All right, so this one, when you get ones like this, guys, it helps to draw them out because they're triangulating the locations. So Bellevue is 30 kilometers north of Ayer, I don't know how to say that, and Churchville is 18 kilometers northwest of, how do you say it? What do you think?
Air.
Just Ayer? Yeah, sounds fine. Okay, calculate the distance between Bellevue and Churchville. So that means is we have A, so 30 kilometers north, so just straight 30. Okay, and then 18 kilometers northwest of Ayer is Churchville. So this one is B. So it's like that. This is C. Northwest. Yeah. And so this is what's the distance between Bellevue and Churchville. So we're trying to find BC. So what we know is this is 30 and this is 18. And when you say, if you do direct distance, direct northwest, then what does that angle turn? What did you say? 45, yeah. Yeah, 45, yep. I'm not sure if you said 35 or not. So that's 45 degrees. Because 45 is halfway between north and west. Okay, so you can see we have the cosine law set up again. So we are going to go... we're trying to find A, so it's still the same form. A squared equals 18 squared plus 30 squared. Remember, order of these doesn't matter, okay, because you're adding. So it doesn't matter if you put 30 to 18 first. Yep, so it's on your book. Remember, you can always check and look in the back of your book, and I'll tell you what formulas you get. But you do get this. Okay, so you calculate that. You're going to get A squared is 460. 0.32. Square root. A is 21.45. Okay, a couple things to consider when you get answers like this. So I got 21. Is that in the ballpark of the other lengths? Yeah, 18 and 30. So that means that Churchville to Bellevue is closer than Ayer and Bellevue, but farther than Ayer and Churchville. Okay, so 21.45. Okay, it said nearest kilometer too, so we'd round this to 21 if you just said nearest kilometer. Okay, we'll wait. So here we go. So sometimes it's helpful to arrange them differently. So all they've done, there's another way to do cosine law, and that is simply solving for the cosine. So kind of moving everything else over is what they did, see? And the reason why, well, to see if you can make a guess. Why is it helpful to maybe do it this way? Nope. We get a good idea, though. They kind of give it away right here. Well,
Any angle in a triangle when you're given the length?
so if you're given all the sides but you don't know the angles, you don't have a comparison, right? So if you're given all sides, then this is what you're going to be looking for to find that missing angle. Okay? So if you give also, because remember, triangles can change in size, right? Okay? But if you have the sides, you have a ratio of sides all the way around that gives you a ratio of what the angles have to be. So what I'm saying is, like, if I know that 70 is my biggest length, then that's going to give me a type of degree that's going to match in terms of the biggest side. Okay? So just think about it that way. Okay? Got it, Miller? Good. Just make sure. Sorry, you're on suspension, so. Okay? All right. Complete the following for triangle ABC. So cosine of B. So I want you to fill the formula out for just cos B instead of cos A. So let's actually leave this here so we can see it. So see the pattern? A means B squared plus C squared. So B means A squared plus C squared minus B squared all over 2AC. The cos C one would be A squared plus B squared minus C squared all over 2AB. Oh, sorry. 2AC. No, that's right. This was wrong. This says 2BC on the bottom. Liars. Okay. All right, we're going to do 2 examples of that and call it a day. Call it a break. All right. Determine the largest triangle ABC. So determine the largest angle in ABC. Now they're giving you 3 sides. Now here's 2 things I want you to be able to do. Okay, so let's go ahead and just draw this triangle here. Let's see if I can cheat a little bit, actually. Yeah, all right, let's put this here. Okay, so, yeah, that's right. All right, so 14.7, 12.6, these aren't to scale, obviously. It's actually like almost equilateral, so just we're using this just for being close. Okay, 8.9. Now I'm going to label these for you. Okay, which angle do we expect to be the biggest? A. Because it makes the biggest side. So that's all we're going to go for. So we're doing the cos A one. So we're going cos of A equals B squared plus C squared minus A squared, and then plug it in. So cos A, so B squared, so that's going to be 8.9 plus 12.6 minus 14.7 all over 2 times 8.9, 12.6. Okay, so that's what you plug in. Remember, now that you have a big fraction bar, maybe do the top, then divide by the bottom. Make sure you use brackets if you're going to do it all together, else the bottom will divide by 2 and multiply by the rest. Okay, so make sure you use your brackets. When you do that, you're going to get cos A equals 0.9. Where's that? 0.0975. Okay, before you guys find this angle, I want you to think about something. Unit circle question. In the values of the unit circle, is 0.09 small or 0.09 big? Small. Good. Because 0.9 is big, right? 0.9 is close to 1. Remember, our values in the unit circle go from 0 to 1. So I said, is 0.09 big or small? 0.09. The one right here. So I'm trying to tell you.
Oh, right.
Right. So what is cosine right here on the unit circle? What is cosine right there at that dot? 1. What's cosine right there? 0. So 0.09 is going to be really close to that second dot, right? It's going to be like right about there. So what's an answer that makes sense to you? 86, 87, right? Because that's close to 90. When you cos inverse this, you get 84. So I'm just kind of getting you some context of that number sense of why that makes sense. It's 84. It's close to when cosine is 0. Cosine is 0 at 90. Okay, make that connection. Okay, questions? All right, last example then. Two ships set sail from port B heading in different directions. The first ship sails 7 kilometers to R. The second ship sails 8 kilometers to Q. If the distance between R and Q is 13 kilometers, determine the angle between the directions of the ships. Okay, so we're trying to find that angle. The ships are R and Q. Okay. So we'd be simply doing cosine of P equals 8 squared plus 7 squared minus 13 squared over 2 times 8 times 7. This is interesting, and I want to see if you can pick this out. If somebody gets this right on the first guess, I'll give you full marks back for Moodle corrections on the Moodle quiz.
No. Don't. 6.
Oh.
6. Yes, you got it. Okay, so what happens is we get then cosine of P equals negative 0.5. What does that mean? Okay, wait. Just let people think. It's a big time question here. So being negative 0.5, what can you expect? Okay, so
Everyone gets Moodle quiz marks.
yeah, so it's fine. You guys got it. So what I want you to say, what you said, and then she actually said as well, there's two things. A negative value for cosine, right? The negative value for cosine means we're out of quadrant 1. Now, the silly thing I was kind of hoping you would say is, has to be in quadrant 2. We're dealing with triangles here. We can't be bigger than what? 180, right? So our only two options are up here. We can't be down here. These are 270, 220. Those aren't possible for a triangle. So that negative 0.5 is telling me I'm up in here, which means it's an obtuse angle. That's what I was kind of really the full. It's a negative value for cosine, means it's bigger than 90, means it's an obtuse angle because it's bigger than 90. But you guys did a lot of those things. It's good. So all we do here is we cosine inverse this. This is actually negative 1/2. This is on the unit circle. So you don't even actually use your calculator if you're doing your project. Negative 1/2. How about you know this one? Nope. 120. It's 120. 135. Wait, 135. That's 45. That's root 2 over 2. Remember, the 45s are the root 2 over 2s. Yeah. This right here, that's the one we want because that's close. That's negative 1/2 for cosine. So it's this 30 past 90. So 120. Okay. In all seriousness, guys, I really hope by the end of this course in this unit that you can, when I say where's cosine negative 1/2, you can tell me 120 and 240.
Question.
Yeah.
So when you say 1, you're talking about it's up on 90.
Mm-hmm.
1.
Yep.
Negative 0.5, negative 1. Why would you want 120?
No, because good question. Okay, I see what you're saying. Yeah, so the ratios don't work that way because that's, oh, I see what you're saying. So this is 1, negative 1/2 to 1. Yeah, it doesn't fall in line that way. Yeah, it doesn't fall in line. What's root 2 over 2? Like the value, I forgot. What is that? Can somebody find that real quick? But we're done. We'll stop the video, so.